Howdy, everybody in YouTube land. What we have in front of us today are a pair of Powerbook 180Cs. And of course, it's all the usual problems that plague all of these Powerbooks, but this particular set I've had for probably over a decade. I bought one a little later for parts, but the other one I had since I was still living with mom. So I have both of these machines. Now, the problem with these machines, actually, there's several problems with this machines. This one, I kind of worked on it back then, and I've not done anything with it. And I think this one, we've got two problems. So problem number one with this one is right here. So that ribbon cable is damaged by capacitor goo. So that display has got lines across it, and there's no fixing that. So that was a parts display. So that's kind of why that one got sidelined. And then the other issue is right here. The standoffs were broken. So I tried to epoxy those back in place, and I got epoxy in that hole, and it won't come out. And I'm like, you know what? So I cast it aside, and it's just kind of sat ever since. Now this one is a different story. This one's got a really big scratch in the glass, but I did recap the display. But I don't remember why I stopped working on this one and never completed it. So I don't know. I can't remember if this display works or not. I'm going to have to test that. But more importantly, again, we've got a similar problem here. So I JB welded the standoffs in place, but notice the JB weld is turning a darker color because this used to be gray and now it's turned like a brown, and it's starting to corrode the metal. So JB weld is not very good for that type of thing. So that's gonna have to go. So what I've done is I went on eBay, and I've heard some mixed stories about the seller who's selling these. I don't really know personally, but right now he's the only one that sells these. So I bought a couple sets of them. So these are 3D printed standoff thingies for the hinges. We got to clear all that out and sand it down and make these on. Now these are grooved. And they're grooved on purpose because it's there to allow the epoxy or glue or whatever you use to kind of fill in and grab. So these, the way these actually work is they kind of go here. You got to line them up. Alignment is critical for obvious reasons. So they line up here and here, and they kind of just glue down in place. So we have those. So we can at least try to fix these machines. Now, step one though, before I go any further, I want to actually kind of just hook this stuff up. And, there's some crap in here. I want to hook this stuff up and see where the operational condition is with the machine themselves, because I don't know the operational status. I don't know if the logic's good. I don't remember if this panel is any good or not. This panel is screwed, so there's not much I can do about that for now. But I can work on this one. And between the two machines, I should be able to make one work. I might be able to make both work because you'll see in a minute. But for now, let's power this up and try to get this wired up on the bench and see if it works. I hope it does. Alright, so after digging and digging and digging for my 3 amp power supply, because the 180C requires a 3 amp power supply or it won't work. So let's see, what do we get here? The glare of the light's going to be a problem. Let me unplug that. Here we go. So the screen is working. There's no flaws. But I don't hear a hard drive, so maybe that's what it is. I was missing a hard drive. Because I worked on these machines before Blue SCSI was invented. Before Zulu SCSI was a thing. So this was a long, long time ago when I worked on these. And they've been through 2 moves. Because I was working on this when I was still at my mom's house. That's how long I've had these machines. Anyways, so, yeah, besides the little scratch right here in the polarizing film, which is hardly even visible. It's working fine. There's nothing wrong with that screen. All right. So this logic board works perfectly fine. So we are good there. Now, all of these things need recapped by now, but I have no idea how to get these open. So, anyways, okay. So, all right. So this circuit works. So we're good with that. I'll move on to the other one because I have a second one here, which has a hard drive. Probably no good, but we'll see if it works. All right. So now we're on to number 2. Let's see what that does. Dead. Actually, no. It came on. Just had no sound. Who knows why that is? Yeah, that's this one's dead. And we get no spinny. Alright, so at least with this one, we kind of know this one has a logic problem. And I think that's what I remember. Because this is the screen that went to this unit, I think. And the one that worked had the bad screen. So, yeah, this one's done. It turns on, but there's no chime. There's no hard drive activity. There's nothing along those lines. So we've definitely got a problem with the electrical circuitry on the logic board. Now, the 140 schematic is out there. This is the 180. So I don't know. They're going to be very similar, but they're not going to be the same. The DC-DC converter sections are all very similar, so I can do that. So we've got a good panel, at least. But we've got a bad... Yeah, this thing is not good. So we got a problem here. Alright. Okay, so let's get this off the bench and let's see what we should do next. Let me get the working unit over here because I want to check the other LCD to make sure if I'm remembering properly. Alright, so I got the screen with the damaged cable connected, so I want to see what this one does. Because I do not remember. Alright, so we got a good backlight, chime. Yeah, that's done. Yeah, that's what we had. Yeah, that's... We got an issue here, too, on this cable. But yeah, that's what it was. So that screen is for sure dead. Alright, so we know for a fact that screen is just completely gone. So that's okay. We have a logic fault with the other machine, but I think what we need to do is I want to check some other things. So we've got one machine that we know has working logic and a working display, but with busted hinges and stuff like that. We have another machine that has a bad display and non-working logic circuitry. So what are we going to do about that? Fast forward to 2017. We have 3, not 1, not 2, but 3 LCD panels for this machine. So between all of these, I'm hoping we have at least one more that we can use here. Now, all of these are going to have disgusting leaky capacitors. Whereas I've already recapped that display. Well, not that one, but the other one. So I'm hoping, because this one's got a really good backlight CCFL, so I can hang on to that part, because it's getting harder to get that stuff. And we can go through these and see if there's anything in here that we can scrounge together, because these are all parts displays, so I don't know what's good, what's bad, etc. So we can use, hopefully between these 3, I can make something to work over here. So we need to get this apart and actually go through them. So I got the displays kind of sorted. This is the worst one of the 3. where the capacitor juice is actually pretty bad in here. So what I'm likely going to do in this case, oh yeah, you can see the wetness. So what I'm going to do here is I'm going to clean this up first with some rubbing alcohol before I even think about firing this one up. Because I want to test it before I recap it, right? Because if it's got damaged ribbons, there's no point. I'll get rid of it. So, yeah, I'm going to clean this up first. Make sure it's good. And then that's it. We'll go ahead and put a big check mark on this one and then cut the caps off and move on to the next one. Yeah, I just cleaned this up and this thing's pretty bad. I don't know if this is ever going to work, but yeah, it's eaten up pretty good. There's some corrosion left behind. There could be some open vias or traces. I don't know yet, but I got it cleaned up as best as I could. I'm going to energize this panel and see what happens. So here we go. Looks like a little liquid in the backlight. Whoa, it works. That's working. Nice. Trick was cleaning it up before energizing it so it didn't damage anything. So this panel is good to go. I just got to recap it, but this is a good one. It's got some liquid damage in the backlight, but that was probably me, which is fine because I have another one. I can swap the panels around. So that's not a big deal, but that's okay because I didn't feel like taking this all apart, removing all these screws, and risk damaging the panel flexing on it while trying to clean it. It was easier to keep it all together and just clean this area as best as I could without it migrating in. But anyway, so it's actually not bad. There's some issues with corrosion there. I'd like to pull these chips and clean that up, but right now it works. So this is a good panel. So number one is good. I can move on to the next one. All right, so here we are with panel number 2. Let's make sure this one's good. Looks like it is. All right, no weird lines or anything like that. That panel is good. All right, so let's move on to panel number 3. All right, so this is panel number 3. Let's check you out. This is the one that has the least amount of cap goo damage. Actually, I can't even see any. Physically, oh, that one's got a red tint to it. So that one has worn out CCFLs. A lot more hours on it. But it works. But that one's going to need new bulbs. But otherwise, it works fine. So that's awesome. We got 3 for 3. One just has some weak bulbs, but that's fine because I can take the bulbs out of the one that has the wet polarizer or wet diffuser film, move them over here, and then take that panel and move it over to the other one. So that's it. We're good. So this one's got bad bulbs in it because what happens when CCFLs age, let me get the light on. What happens is when CCFLs age, they turn more and more red. So your picture is going to start looking more red. Right? Now, if the polarizer, not the polarizer, I keep saying polarizer, when the diffusing film starts to yellow, your picture is going to get a little bit more yellow, right? But not red. Red is the bulb itself. Yellow is the diffusing film. So, all right, so we got 3 for 3. So now we just have to clean these guys up and recap them. And I don't know if I'm going to recap all of them, but I want to figure out the best one of the 3 to use in here. Recap that one and just remove the caps off the other ones so they don't continue to do more damage. So here's what we're going to do. Here's my current plan. So this is the one that's the cleanest with no cap goo damage that has the backlight issue. And then that's the one that has the damaged ribbon that has a fine backlight. So what I'm going to do is I'm going to take the glass panel off of this one and move it over to that one. But before I do that, I'm going to recap this thing. And because I'm lazy and I want to cheat, I ordered a capacitor kit from Console 5, which has the caps for this particular display. So we're going to take you, put you in here, and then that should be good. There's only two values. There's 47s and 10s. Now, there's a couple different voltages in 10s, but they're still 10s. So they chose to use three of the same ones that go there, and then the rest of them. These might be the two 10s for here, and these four are probably these four there, and that's fine. So that's our current plan. Is I got two cap kits here because I had two machines. So this cap kit will be dedicated for this, and then that'll work. That'll leave this one with the bad backlight, right? But remember, we got another panel that the film got a little bit wet, so I can move those tubes into this one and that panel into that one and recap that, and now I have two that are recapped and ready to go. And the one with the scratch can be a backup spare for the machine because there's nothing wrong with the spares. And that'll leave two more that will need caps. I can remove the old ones and save them for later, and they can get put up, and then that'll leave one left over that's just junk. So out of 5 panels, I'll have 4 that worked. So at least that's the current plan anyway. So step 1, we got to do the caps, clean all this up, and then start transferring parts around. Actually, pump the brakes for a second. That plan may have just changed because I just noticed something. There's like these rings in there. But look, when I hit the light just right, you see that? They're like flat spots. That is, I think, the polarizing film on the rear of this panel starting to degrade. You know, going into vinegar syndrome, basically. So that is an issue. Okay, this might actually just get thrown in the parts bin for now. I can fix it later. It's not a big deal, but that's an issue. Let me get the glass panel out so I can take a closer look, just to make sure it's not something silly like the polarizing film, or not the polarizing film, but the diffusing film or something. But that's kind of not. Yeah. That was a royal pain to get off without breaking the glass. I had to get up under here and just slowly pull it up as I'm using the heat gun to heat it up because this rubber is really stuck down to this panel. So I experimented on the bad one because if I cracked the screen, I didn't care because this one's damaged anyways. But see, there's the rear polarizing film, and when you lay down this film, it's got to be exact. It goes around the border. Because if it's too wide, well, look what happens. You run into this. So, yeah, it's got to be exact as best as it possibly can. So, what I've done is I've taken a closer look at this one. The one I got these spots in. And if you look very carefully, I can see. See how I can... You see that? That's the polarizing film. So the polarizing film is coming up on that. I can't do anything about that now. So I'm going to have to take this guy and mark on it. We have a backlight problem. Yeah, we have a backlight problem. And then we have a polarizer problem. So it works, but we need a backlight, CCFL bulbs, and we need a polarizer. So you are going to go off to the side. This will be a backup for another day, I think. But in the meantime, I'm going to get all these off so it doesn't continue to cause more damage. So we'll definitely do that, and then we're going to put that aside, and we will move on to the next one. But I'm definitely going to need you, so I got to set you out of the side, and then that's it. Yeah, this display is really nasty. So I took the other display, I took the caps off and cleaned the board up so it wouldn't get damaged any further. And that one is going to go in my spares, I guess. So I grabbed another one that we just tested and it worked. I made a check mark. But this one is really, really nasty. So I got to clean all of that up. And hopefully this one will be one of the two that goes in the one that works. But this one, if I remember, this is the one that has the damage to the diffusing film. So I got to move the panel out of there into that one and make it work, I think. Now that I have the new caps installed, I want to double check this display real quick and make sure it works. Not only that, but also to see if that little spot went away in the diffuser film, because that could have been from cap juice or whatever, and it's probably still there. So also, the other thing I wanted to say is the acetone actually cleaned up the oxidation or the salts left over from the cap goo fairly well. Actually, it did a really amazing job on that. Because remember, this was extremely white, and now it's, I mean, it's a little dingy from the corroded solder, but there's no more that crustiness on it. I cleaned it up with the acetone and toothbrush and Q-tips and stuff like that. So hopefully this will work. Alright, so here we go. Let's plug the power in, turn it on. Cut that light off. Yeah, I can still see the damage in the polarizing film. So yeah, this little guy is going to have to come apart, unfortunately. Make sure the brightness works, and it does. So yeah, I'm going to have to take the panel out. That's unfortunate, because you can see it really well in there. So this polarizing film got damaged. It's hard to say how. I don't know if I got it wet by accident when I was cleaning this up with alcohol originally, or if it was like that from, who knows, I don't know. But I've got to replace the panel by moving that over onto that substrate here with this diffusing film, which gives me the ability to free up the CCFLs that are in this guy and use it on the one that's overly red, right? But I'm not going to worry about that right now because that one's got bad polarizing film. So anyways, so that way we're all good there, I think. The backlight's kind of weak on these, but anyways, moving right along. Now that I got it removed, which you got to do extremely, extremely carefully because the rubber is just stuck to the glass. But anyway, so I got it out of the way now, and you can see the polarizing film is damaged, and it's been that way for a while, because if it was something I did, it would have dried up and it wouldn't have been a problem. But that's been like that for a while. So that film is just gone. So we're gonna have to, like, I might actually be able to clean that up, but I don't know. It's probably going to be easier just to move that over to that guy and just make one screen out of two of them, because that one's junk anyways. So yeah, I think that's where we're at with this one. Alright, there we go. LCD's all put back together with the other diffusing backlight film thing. There's a little bit of scratching on the polarizing film, but this stuff, who knows where it came from. It's never going to be perfect. So let's go ahead and get her plugged back in. Make sure everything is good. Make sure I don't have any weird little things in the polarizing film, and it doesn't look like that I do. And more importantly, the screen works. Trackball's shot, but not surprised there. So there we go. It looks so much better now. We're all recapped, we're all cleaned up. So display number 1 is good. So now I want to work on display number 2. Make sure we have a good LCD, at least 2 good LCDs. This is number 1. The other one's recapped, but it has a scratch in it, right? So I want to make sure everything is good there. One thing I noticed, though, is the rubber, that little rubber pad kind of smooched out a little bit, but I don't think it's going to matter so much. All that rubber really does, actually, it's doing a couple things. One, it gives cushion for the panel, so there's not uneven pressure on it. It can cause distortions. But more importantly, it helps keep the dust out from getting in between the panel and the backlight. So, alright, so we're going to move on to the second panel. I'm just going to skip ahead here. because it's basically the same thing we just did. So I'm going to do that, test it, make sure it's good. Then I think we need to start working on the LCD upper display assemblies and getting those in there. That's going to be fun. That's going to be the worst part of this entire project, I think. And then we got to fix the logics on the other computer, things like that. Well, here comes the bad connections in the panel. That sucks. I've been letting it run for a bit just to see what it would do. Yeah, you can smell the cap goo emanating from that circuit board. It's just, the problem with this stuff is it gets into the board and it absorbs it, and it starts to outgas when things get hot. And I washed this board. So, yeah, it's, Now, unfortunately, I think it's got up inside this ribbon, and this is why this is occurring. I got one line, and then I got another line showing up. It's so bad. Dang it. So I'm going to have to move on to the next LCD. Alright, well, now I got the thing off of it, and let's see. I want to take a look at you, if I can. Don't know if it'll let me actually get in here. Maybe. No, maybe not. How about if I take a flashlight to it? Oh, there we go. You can see the little black marks in the cable? Like right there. That is basically the traces eaten away inside the cable from the capacitor goo. Even right in here you can see it. So that's unfortunate. That's basically what's wrong with the other panel. So that's not repairable. So this thing is junk, unfortunately. It's possible I can take one of these cables off of the other panel, like down here, and move it over. But I'm not sure how to do that because this is like hot bar welded on. So yeah, I know there's people that can do that because they fix modern OLED displays and stuff all the time. But I'm not sure how to do that. But unfortunately, that's it. So I'm going to have to go check the other displays and see how bad those are, because it's getting to the point where I might not be able to fix any of these, because if they all have this damage, they're all going to do the same thing. Alright, so this one's recapped, and it didn't quite go according to plan because this one was eaten away so bad that the pads came off. So I went ahead and done all of that. So now I did check these ribbons before I wasted my time like the last one. And this one is not eaten with the traces going to the panel as far as I can see. But the traces on the bottom have a little bit of damage. These. But those are patchable. I can patch them because they're far enough apart, and I can use conductive ink if worse comes to worse. But I just want to go ahead and I tried to wash this board a little bit with the alcohol and acetone bath as much as I could, because I can't remove these ribbons. So it's not like I can wash the whole thing. That would be silly. But I did the best I possibly can, and I tried to heat soak this and bake it to try to drive everything out. So I'm going to plug this in the machine, and I'm going to let it run and see if I have any more issues with this panel. I'm hoping this one's a winner. We'll see. I'm not holding my breath, but hopefully this is a winner and we can move forward. Well, this one's been on for about 10 minutes so far, so I think we might have a winner. I'm not getting nearly as strong of an emanating capacitor goo smell from the board, unlike the last one. So where does that leave us? Well, this one is probably going to be okay. I'm going to let it run a little longer, and if it's okay, I'm going to clean it up and put it together. So out of the 3 displays that I had for parts, only one's good. Because the other 2, well, one of them is screwed. We just saw that was one of the 3. And then the other one's got a bad polarizing film on the back side of the glass. So that leaves only one. Now the other panel is got that scratch in the polarizing film right there, but so far it works. So I think what I'm going to have to do is that gives me 2 options. I have to replace the polarizing film on the back side to get it right, and then I have to replace the polarizing film on the front side to get it right. So either way, I got to replace polarizing film. But I think for now, I can probably live with this one that has a little bit of a scratch on the front. But what I'm going to do is I'm going to take it apart, inspect the board, and inspect the cables and make sure that it's okay. Because if not, then we're going to have a problem. Because of the darkness that's in the lines, there's current flowing through those control lines. You can kind of see with the light off or coming through, you can see all of these lines. Well, if those connections are bad, you're going to start getting, you know what I mean? So the issue is, I don't know how you can actually remove these ribbons from the glass. I don't think that you can. You might be able to do it with a hot bar, but I'm not sure on that, because this is the type of stuff you need specialized equipment to work on, kind of like rebuilding a CRT. Now, again, as I mentioned earlier, I've seen videos and websites where people work on smartphone glass displays and they're able to replace this stuff. But I don't know how they do it, and that's what needs to be done here. So between those two LCDs that are bad with the same exact fault, I can make one work by taking a ribbon from one and moving it to another on the other. Just, but regardless, that's where we are. So I'm going to let this run some more, and then I'm going to go look at the other one. The fun part's going to be dealing with these broken hinges, and they're literally just crumbling apart even after I tried to epoxy them. And these didn't even stick to anything. Alright, so I got all the old plastic cleaned up, and I'm using this grinding bit for the Dremel to try to clean up all this old crap, and then I'm going back with the sanding block to rough it up a little bit. It's not perfect, but one thing I've learned is when I tried to use JB Weld on this one, it actually ate into the plastic a little bit, and I'm assuming it's designed to do that. The issue is the JB Weld makes the plastic a lot more brittle where it bonds. Because I've noticed with this one, when I was cutting the standoffs off, it was really pliable and it was hard to get them off, because this plastic is actually still good. Problem is, these standoffs shrink with time, so they break. That's what happens to them. But this one was extremely brittle, just crumbled into pieces where that JB Weld was. So yeah, that's important. Don't use JB Weld on this stuff. So that's an important lesson that I learned. Anyway, so what I'm going to do now is I'm going to mix up some of this Loctite epoxy stuff, which is supposedly good on plastics. So I'm going to use that, and I'm going to go ahead and just bond these up. Now, the issue becomes trying to align these. So I left the holes in place so I can kind of see where they go, and they line up almost exactly, although there's some differences. But one thing I've noticed is it lines up about where these are. So I'm thinking that's how these were designed. I'm not sure. So the difference is on this side, there has to be room for the backlight cable. So we have to make sure the backlight cable is lined up as well. So yeah. So that's what we're going to do here, is we're just going to line this guy up as possibly can. And then that's it. And hopefully that should solve our problem. I did all four at the same time. That way I can use this one-use tube here. And then bang, 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 bang. Just mix it all up and then bond it down. At least that's the goal anyways. It'll be interesting to know if these, because one thing I've noticed with this particular design is they did a honeycomb slice instead of actually filling this in like they should have. So I don't know how well this is going to hold to torsional forces over time. But also, this is the other wild card. I don't know how well this is going to hold for torsional forces. But I do know this stuff is strong, because I used this to hold the USB ports on the Prison Book, which is a different laptop that's not part of this video. And it's not coming off. Well, it's the point of no return. It's either going to work or not. It's either going to be in alignment or not. I don't know. It's very hard to do. Alright, so hinge plate thingies are reinstalled, well, standoff things, and I got the brass standoffs installed. Now, one of them was filled with epoxy, so I had to dig through my junk screw bin from old PowerBooks that I scrapped out so I can find a new one to insert there. It's slightly different than all of them, but they're all there. Now they all thread through because there's the screws that go in there, and they all thread through just fine. So now what I've been doing is I can heat these up with a soldering iron and I can move them around a little bit. Not a whole lot or it'll come out, but I can move them around a little bit, which will give me the ability to make micro adjustments if things are slightly off kilter. So what I'm going to do is just get this guy on here right quick and just try to get them lined up as best as I can physically here. And that's pretty damn close. The same thing over here. If I line this up over here, yeah, it's close. It's not perfect, but it's super close. So if I do that again with this one over here, line this up a little bit, best as I can, and it's super close, but not quite. And let's do the same thing over here with, and it's not helping because these things need to snap in. But if I were to go to snap it in, it's like, you know, it's close enough, I think. We'll have to play that by ear. But, okay, so, yeah, all I got to do now is wait for these to fully cure before I start putting any kind of tension on it. But until then, I'll go ahead and start getting this stuff buttoned back together, I think. Alright, before I start screwing everything back together, I'm going to remove this battery before it becomes a problem, because yeah, batteries like that become a problem eventually. So we're going to pull you out, and I'm going to do that top side by trying to get my iron in there and just work it out, because I really don't want to take this board out. It's not easy or fun. I did look under here, and these are all solid caps, so we're good there. Well, it lines up, and I got 2 screws in there, so I didn't screw the pooch too badly here. Everything looks, yeah. These standoffs are just ever so slightly shifted out of the space, but I can still get a screw in here, so I think I'm fine. Wow, that actually worked out. Now, this thing isn't fully cured, so I'm not gonna flex the hinges just yet. So what I'm going to do now, though, is just go ahead and get the panel and everything put in here, because I had to do this first in order to get this stuff, you know, everything to line up and go in there. So this is the machine that doesn't run, but I decided to do this top cover first just because, yeah. Well, unfortunately, epoxy is not the way to go there. I might have to find something different. Alright, so while I have the LCD displays, you know, re-curing, I'm using a different epoxy this time. I'm curious if it holds. Anyway, so moving right along, while that's got to sit for another 12, 24 hours. So that's going to be curing. While it's doing that, I want to take a look at this one here and start working on the plastics down here. But this particular one is the one that didn't chime, and it just has a white screen only. Well, if we look very carefully, this thing has had a catastrophic failure. So what I'm trying to do is figure out exactly where that is. And I think it's this diode right there. So I need to find out what happened that took that diode out, because that is definitely a problem. So anyways, I'm going to get all this plastic figured out first, and then we got to find out what happened to this board. So I'm troubleshooting this thing, and I tested the diode, and it's not bad. And I've got all my voltages everywhere. Like, I got a bunch of 5 volts, 7.5 volts. I got a 12 volt, a 9 volt. That's fine. All my voltages are fine. But I just realized something. What's missing in this picture? And no, the heat thing is over there. So what's missing in this picture? That might be important. I only have one of these. I don't know where the other one went. So that's a problem. Let me put this in there and see if that makes a bit of a difference. I bet it does. All right, let's see here. No. Oh, there it is. That'll definitely do it. Yeah, it kind of needs the ROM card and RAM, of course. So I need to go look in my stash and see if I even have a card for this one. Because if not, well, that's an issue. So I gotta look around. Alright, now that it's been basically 24 hours, I re-glued that back in, but this time I used a different type of epoxy. The JB Weld version of the plastic epoxy. Not the metal epoxy like I used in the past, but the plastic epoxy. So hopefully it holds up this time. That one is still the same exact epoxy I had before, the clear stuff. So yeah, well, I can only hope. So I'm going to put this thing back together again and see if it actually holds this time. All right. We're holding together for now. I don't know. Anyways, so I've put this thing together, and I know I'm tempting fate because I have no idea if that original hard drive still works or not. So we're about to find out because I do not know. Let's see. Ooh. That did not sound good. Whoa, it's starting. Yeah, that thing did not sound good. Did you hear that? It's working though. That's actually amazing to me. That hard drive is actually working. Wow. There it is. Well, we only got 4 megs of RAM because we need the little expansion card that goes here, which are incredibly hard to find. There's some reproduction ones on eBay for the other models, but they don't fit this one. The pinout is the same, but the physical dimensions and how it goes in is completely different. So, yeah, that's unfortunate. I have to make one. But other than that, it's working. So, actually, you know what we should do? I'm not going to go through any personal files or anything. Okay, the trackball needs some work. Yummy. Well, there's your problem. The early days of multimedia is so interesting. But I got the trackball working properly now, finally. That's just so interesting. Definitely going to have to get a blue SCSI solution for this thing because I'm using this computer a little more. The trackball's working fine now that I got it all cleaned up. Now watch this. Yeah, you hear that? That hard drive's done. And what it is, there's a little rubber bumper that's underneath the platter, and the head's just, it's gone. Anyway, so I played with it. I went through the drive to see if there's any potential software I wanted to save. There's nothing really on there. So I just went ahead and played around with it, stuck a blue SCSI in it, make sure everything was working on that front, and it is. So it's all good with this machine. So the only thing I have to do now is just get a actual SCSI solution for it. And that will solve our problems there. So I'm going to set this one aside, and we're going to work on the next one, which I'm still waiting for some parts to arrive, and I think we should be good there. All right, so while we're waiting on parts to arrive, because I got to get the ROM RAM board for this one, because that one seems to be missing for some reason. I don't know why. Maybe one of the 180Cs I bought was a parts unit and it was missing it. I don't remember. It's been so long. Anyway, so I had to go on eBay and order one of those. And then I also have blue SCSIs on the way I have got to get for these things. So I can't put the other one back together just yet. But while I am waiting for parts to arrive, I might as well start getting all of the standoffs glued back on this one. So what I do with these is, what I actually do is I grab that MEK stuff and I bond it back down, but at the same time I also take my soldering iron and I heat up the standoffs, and I actually let the standoffs melt back into the plastic while I'm squeezing the post. That way everything is gripped properly again, so it doesn't pop loose, and the heat will transfer into this and bond it even further as well. So at least that's the theory anyways. Well, it certainly ain't pretty, but it'll work. So again, what I did was use that stuff here, which is just MEK, to just kind of bond the cracks, fill in the cracks. And then I heated the standoff and then squeezed it with that while heating it. So then everything just gets all bonded in. Because what happens is the plastic shrinks and the brass can't shrink with it, so it splits. But if you heat this, the plastic is already shrunk. So if you heat this and squeeze on it, it's going to bond itself back in. So it won't do that anymore. At least it shouldn't. So, alright. Alright, so in this one, I went ahead and replaced the rollers because they're starting to go out of round even after cleaning them. Well, the other one I didn't clean, but I cleaned that one. So I was having some issues with it. So I went ahead and replaced the rollers with some 0.8 millimeter inner diameter tubing, silicone tubing, which I just cut with a razor blade to the sizes I need, and that actually solves my problem. So this is the method going forward, because they're even worse on the Macintosh portables. So there we go. That's our solution for the rollers anyway, so I can go ahead and reassemble that. Alright, so trackball is in place. And what I've decided to do was I added a CR2032 battery holder on the back of here. Just ran the wires to the Kensington lock, which nobody's going to use anymore. And what I did was I put a very low drop diode in there to prevent it, because the original battery, which is here, what is this, 2320, this is rechargeable. So it's kind of like the way those old Vardas used to be. So I went ahead and just replaced that with a fixed battery. Now, what I don't know is what the draw on something like this is going to be. So I don't know how quick it's going to run a battery like that dead. But the important thing is I just placed it on the outside so I can service it easily. It's right here now. That way I don't have to mess with it. Had to do the same thing. I had to squeeze and glue the standoffs. But all of this is back together. I'm still waiting on parts, but I can go ahead and get the screen put back together. Alright, so fast forward a little bit of time, we have all of that together. But more importantly, that has come in, so we have that installed, and then I found that in my stash. Now I think this is for the 140, 145, so it's going to add one weight state to this machine. So I don't know if the performance benefit would be worth it or not. I will have to see. Also, I don't have any blue SCSIs. I just do not. So unfortunately, I have to install a SCSI to SD version 5. Now, I've had this probably for 6-7 years before the blue SCSI was a thing. And I bought that for this project that long ago, and I'm just only now getting around to it. So I'd prefer to have a blue SCSI in here that has Wi-Fi, but I've got to go with what I have. So that's going to get thrown in there. I also added some tape back here to try to insulate this. And I think we're it. This is it. So we're going to go ahead and put this guy back together. All right. So here we go. Yay. Now this thing does not have an operating system on that SCSI to SD adapter, so I'm going to have to install one, which I'm just going to use this emergency disc to start the system. Utilities, let's see, discs. It may not. Ooh, see some streaking. There it is. All right. Wow. Yeah, I'm seeing that. That's not good. So, oof. That's probably caused by the ceramic capacitors I used. Because that's all I had on hand when I made this or recapped this thing years ago. So, I got to go in there and fix that. But before I do, let's just get everything set up and make sure it all works. And there we go. This thing is really quick. So, I didn't do a system install. I just threw the system tools folder that's on the SCSI to SD. So if I reboot this thing, it will start up System 7.1 really quickly. It's kind of impressive, actually. It's almost as fast as System 6 is on an SE. That's pretty quick for me, I think. So yeah, we're up and running now. Yeah, I had to make me a little disk tool startup disk so I could actually set this up because this contains the proper tools I needed to format the drive. See, it's got all my SC HD setups. I have it set to where it's detected by both of them, including the patched ones, so everything's all good there. Problem is, these take for eons on a 1.8 gigabyte SD card, so I used the Blue Disk Manager to format it and then installed the driver from the HDSC setup, so we're all good there. All right, I think that's gonna do it for these. So I took that RAM expansion back out of there because it was killing the system performance, and that's probably because of the inserted wait state that those do, because that's for the 140 and not the 180C. So, all right, so a little bit of time has passed. Several things. Now, this particular thing, I put this in the PowerBook 180C, and it was detected. Remember, I was getting weird bus errors, bus arbitration errors, and stuff like that. But I used the Apple HDSC setup, and everything was fine, or so I thought. Now, I, for some reason or another, every time I would install a system software on this thing, it wouldn't boot. I would either get a sad Mac or I would get a bus error or some other strange situation going on, and I'll link some pictures somewhere in here so you can kind of see what was going on with it. So we got that problem, and then it's like, okay, well, let me try a different formatting tool. I tried a few different formatting tools with different drivers, and I was having all kinds of weird issues. There were times where this thing would not mount if I was starting it up off a floppy disk, and I'd have to run SCSI probe to get it to mount. I tried downloading the latest firmware for this thing and enabling the Apple quirks or whatever they call it. I turned that on, and it just doesn't work. So, and sometimes I can copy a small system folder off of a floppy disk onto this thing and then reboot, and it would work fine. But if I tried to install any version of system software, version 7.1 would work fine. It would do the full install, but I'd reboot and I'd get a sad Mac or bus error or all kinds of weirdness. But then sometimes if I would do a 7.1 install, especially 7.5 and newer, it would give me an error saying it has encountered a problem and your contents on your disk are unchanged, blah, 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 blah. It was like, what the hell? So then I decided to grab a system folder that's already pre-made from an image and then copy that from the Blue SCSI, external Blue SCSI, onto this, and it would get so far and it would say blah blah blah, a disk error has occurred, and I'm like, what the hell? So I was getting extremely frustrated. So for some reason, this thing does not work. I don't know why, and it was brand new out of the back package, and I bought this several years ago. I want to say 2018ish, 2019. I bought this directly from this person out of Australia, and it was shipped from Australia. So there's definitely something up with this. I did the vendor clone and all of that. I also made the sectors smaller than this particular card to make sure I'm not overrunning the card. I don't know. It does not work in the 180C. So I said, okay, I need to figure this out. I need to make sure it's not the 180C. So I grabbed this thing, and unfortunately, the 180C does not have turn power, so we're going to have to do modifications to it. Then I used this and did an install, a complete 7.1 install with this card on this device, because unfortunately this card does not get recognized in here, and apparently the SCSI or the SD card implementation with this is buggy. But anyways, it's a nightmare. So I went ahead and set this one up with a blank disk image, did an install with System 7.1 onto this, and I had no problems. So anyways, fast forward some time, I ordered these, so I'm going to go ahead and build those. And then these have the Wi-Fi module, so I can do the Blue SCSI Wi-Fi enabled, you know, Ethernet type thing. Anyway, so I got those so I can do both of those. And while I was trying to, you know, do the install, the hinges snapped again. It snapped the first time around, which I think I got on video. So I re-glued it all, waited 24 hours, and it did it again. And it's on the one where I showed the hinges were a little bit warped. So that was a problem. It was a little bit warped. And I think what's happening is because I was tightening the screws down, and because there's warped, it's trying to pull it closer together, which is pulling it away from the lid. So it just kept snapping. I don't know. I'm just theorizing here. So he sent me replacement hinges because they're a little more flat, and I went ahead and installed those. They're curing up right now. The old ones are just laying over there right now, so that they're curing up right now, and we'll get these installed. So anyways, so I'm just going to leave that alone for now and let that cure, and I'm going to get rid of this. This is a piece of shit. I don't want anything to do with it. There's something with it. So we're going to try these out and see what these do. So we need to get those built. Alright, so the first thing I want to do is I want to modify this main board for termination power. So according to the schematics, we have two capacitors here, which are going to pin 5, which is the term power pin. Now I want to reiterate, when I say schematics, I mean the 145 schematics, because those are available. The 180C is not, but the way it's designed is basically the same. So we're going to go from here. Now, this is the main 5-volt regulator, just like the Macintosh Portable. Matter of fact, the DC converter design is nearly identical, with some changes, obviously. It matches more of the Powerbook 100. But, so, this is a filter network for term power, but it doesn't go anywhere. So, what we're going to do is we're going to run a connection between here and 5 volts. Now, this is 5 volts is on all the time. So if you leave a blue SCSI plugged in here and you have a battery, you're going to run it dead. So what we're going to do is we're going to go to the switched 5 volts, which can be found over here. So I'm just going to patch a little Schottky diode from here, and we're going to run it over there. Now this is 5.2 volts, so you'll end up with about 4.8 over here, 4.9, give or take, which is okay. So we'll just run a Schottky diode setup from here to there, and it's going to be a protection so it prevents backfeed from coming in. Alright, so we're tapped in here, we go up, and then we're connected over there, and that's just a Schottky barrier diode, 40 volt, 1 amp. Doesn't need to be anything special. Just got to make sure the forward voltage drop is low enough so you don't get so much sag over here. So not that indifferent of like a regular Mac or whatever. So alright, so what we're going to do now is we're going to plug the blue SCSI in here, maybe. Now, I don't know if this adapter will pass termination power anyways. It may not. Alright, so here we go. I'm going to plug the power in. Alright, blue SCSI doesn't do anything as expected, so now we're going to turn the power on. There it is. Now it's going to give me an error code because I took the SD card out to copy over to the other one. Alright, so termination power works perfectly fine. So there we go. Now I got my SD card in there because I had to take this one out and copy over to this. Turn power on. No error. So we're good. We'll leave that. So we're going to go ahead and put this thing back together. And then I'm going to give a little bit of time for the display housing to cure, and we should be okay. Alright, so blue SCSI is installed, and we're all Good to go. So now I'm going to go ahead and wait for the screen to cure. I'll be back in the morning and we'll go ahead and get this thing put together and we will try it out and make sure that it works. Termination power mod's been done. Blue SCSI's been done. Since this is the Wi-Fi, I added the Danaport emulation enable file. So hopefully that works because that'll be cool. And I think that'll do it. Alright, so it's been a day. We'll see. I hope it holds this time because crap, you know. Alright, so what we're going to do is, just to make this easier, the Blue SCSI does not have a formatted image on it, but this Blue SCSI does. And if anything works the way I want it to, this thing should have power, and it does. So hopefully it boots from that. At least it should. Because there's nothing on this one. So here we go. Does it work? It does. Alright, so we're booting off the external Blue SCSI, I think. Or are we? We should be. Yep, it is. Alright, so the Danaport emulation should show up too. So we will see. Yep, there it is, the legacy recovery. That's the image on the thing. And the Macintosh SSD. So I think the no, it's not. So that's the image file that it created from before. I need the SCSI probe. Hopefully SCSI probe shows everything. Because it sees everything on the external, but not the internal. So let's make sure that's right. Yeah, there it is. Awesome. God, that's so confusing. That is so confusing. Okay, so ID 0 is the internal. That's the external. That's the internal. That's the external. Okay. What if I mount everything? Yeah, there's nothing to mount. Nothing's formatted. Alright, so... Alright, okay. Let's kill you for a second. Disk tools, kill you. Get out of here, get out of here. Because I think this guy has the... There it is. So we're going to have to set up that thing. Yeah, there it is. It shows what it is, so let's initialize it. Alright. It looks like it's working. Or I'm not getting any weird errors like this stupid thing did. Alright, so I formatted that volume, and to make this thing a whole lot easier, we're just going to copy everything that I already installed on the primary over to the secondary, because I've already done all of this work before when I couldn't get this to work. So I figured instead of just starting over again, we'll just copy everything over. And, oh yeah, you know what? That's got System 7.5 on it. So, well, I guess I decided to install System 7.5. I don't remember why I did that. I really don't remember, but I guess we'll find out. Yeah, this Blue SCSI is working flawlessly, and it's quick too. So there's the Danaport, which I think I might want to move it to actually 6, and then leave this one alone. That way it leaves all the middle ones alone for external peripherals. But for now, this thing is really fast for what it is. I think I remember why I put System 7.5 on here. Because my file server has a volume larger than 2 gigabytes. It's actually, I think, a 10 gigabyte volume or 15 gigabyte volume. And System 7.1 crashes when you try to mount it. But System 7.5 works perfectly fine. There may have been a patch for that. I don't know, but it does not work. But it does with this one, but not with System 7.1. But yeah, look at that. That thing's actually moving pretty good with System 7.5 on it. It keeps doing this. I don't know why that is. But other than that, we're running, okay, 4 megs of RAM, System 7.5. We're just using 7.5. I should just say, let's put 7.5.3 on this thing. But whatever. I'm curious if it'll do it again. Turn on 32-bit addressing. Virtual memory is on. 12. Built-in memory. I'll make this 32. Because I got the space. Why not? Save. Special. Restart. See if it does it again. We'll find out. Do. Does it do it again? No. It doesn't do it again. Okay, so now we can move on. I can button this thing up. Well, I got to get the Wi-Fi drivers installed and all that stuff, but I can button this thing up and move on to the next one. Alright, so this is the other machine. The one that has the hard drive that's sounding its death rattle. I'm going to go ahead and pull all that out of here, though, because the hard drive's coming out, and we know why it's failing. Why is it failing? There's a little rubber bumper underneath the platter that's turning to goo, and every time the head parks itself, it slams into that rubber and just gets further and further and further and stuck. Eventually, it will get to the point where the head will slam into the spindle and it'll destroy the head. So every time that drive powers down, there's a threat of it doing that. So as long as the drive stays running and never touches the bumper, it'll continue to run without any problems whatsoever. But otherwise, that happens. So I'm just going to go ahead and pull the drive out and replace it with this second blue SCSI. And that, I think, should do it. And then we'll be alright at that point. Oh, and I think that one also needed, or this one needed it needs the little coin cell battery mod that I gotta do to that, and I gotta do the same diode mod to this one as well. So I took this drive apart just for in the name of science here. So this is where the resting spot or the landing zone is supposed to be, because there's a hook here to prevent it from going out further until it unlocks itself. But that is where it is. That's what was making that god-awful noise. So it's supposed to be somewhere here, not there. And you can see the groove, that's a circle groove cut into it. And there's specks all over this platter. I had to blow it off. So that's the issue. The rubber bumper underneath this platter has deteriorated to the point where the head's just not. Now, is this fixable? Yeah, kinda. But you'd have to rig it. You'd have to put like a bumper here to prevent the head from going all the way over this way, which would stop the cantilever from swinging that way. So you'd have to put something there. So it's possible I could fix this drive, but eventually the rubber is going to melt completely and then goo up everywhere and cause problems. But the more important thing is the rubber is already on this cantilever actuator. So it's done. Now, I could pull all this apart and clean it up, but the issue is it's two platters. So you can't remove a dual platter drive without a special removal tool, or you're going to have cylinder misalignment, because these two platters are precisely in alignment. So you'd have to have a special extraction tool to remove the platter assembly to get underneath it and then mount it back down. That's a lot of surgery, especially when you can pay $30-something for this thing. You don't, unless you want the sound of this, the nostalgic sound of that, There's no way, yeah. And there you go. It was only a matter of time. So that's not repairable without some kind of a hack, but even then it's starting to goo up and go everywhere. And sure enough, it's on the edge of this platter too. So unfortunately, it's done. So I'm going to throw this in the trash, but I just wanted to go through this exercise to show you what's going on. Now, again, the drive worked, but it wasn't going to work for long. And that's kind of why I've done a very early video years ago on this very same thing, but I figured I'd just go ahead and go through it now so you know, kind of what to look out for. So I could technically fix this since it didn't really damage the actuator at all. I could have fixed that. You know, just take the platter extraction tool, remove the platters, clean all this up, replace that, drop the platters back on, and it would have been alright. But is it worth it? Maybe in the name of science someone can do that. I don't have the tools to do it, but maybe someone can. But that's ultimately your issue. There we go. There's our little battery mod for this machine. So I just threw a surface mount diode in here. It's just easier. And it's not in the way of anything. So that's in there. Now, this is a little bit obtrusive, but I'd rather it be here because then at least I can get to the battery without taking the machine apart. And if it starts to leak or something, I don't have to worry about it getting into the machine. And yeah, it's holding up quite well anyways in the other machine. So, alright, so this one's done. Now I got to put it back together. And hopefully these hinges don't snap off. This one hasn't yet, luckily. But, alright, I think we're good. So let's get this guy back together. And here we are, machine number 2. Now, got the blue SCSI in there, which is in a green housing. Let's see. Alright, so let's see if it boots from this one. I hope it does. Yep, looks like it. The LCD CCFL bulb is a lot weaker than the other one. That's for sure. Alright. I want to do this one. I think I'm going to do this one different. I'm probably going to do a System 753 install, but before I do, I want to set the system clock so all of my dates are correct. So, yeah. Okay, Macintosh SSD. That's that image file that I had. So, okay, so let's see here. Yeah. Oh hell, I'm going for it. We're going to install System 7.5.3 onto this machine. It's going to be a little heavy with 4 megabytes of RAM, but at least 753 has everything I could possibly need, like the clock and all of that other stuff. So, here we go. And there we have it. I decided to forego installing 753 on that one because it was taking forever. So I canceled that, restarted, and reloaded the drive. Because I need to wrap this video up because it's gotten pretty crazy. But they're up and going with minimum System 7.5 installs for these machines, and we now have 2, not 1, but 2 functional Powerbook 180C machines. So if you enjoyed this video, don't forget to hit the like and subscribe and all of that fun stuff. And if you have a comment, please feel free to leave one. Until next time, guys, thank you for watching.